Hi, good morning, boys and girls. Okay, I promised that I was going to do the video on benchmark, uh, benchmark fractions. Benchmark fractions, I think I gave you a definition for this. Benchmark fraction um, are, are common fractions, such as 1/2. Okay, the common fraction such as 1/2, which is used that are used to compare fractions. Okay, you can use it to compare fractions or put them in order. All right. So we there are a few different benchmarks that we commonly use. They're like we can use 1/4 if we wanted to. We can use 1/2 if we wanted to. We can use 3/4 if we wanted to. Or we can use 1. And as we said, 1 is a special number because any number over itself is 1. So could be 4/4 is equal to 1. Okay, so that's a special thing about um, benchmarking. These are the numbers that we are doing. Now, yesterday I promised that I was going to do this video because I was asking the question, which benchmark is between which benchmark is between two fractions such as 4/6, 4/6 and uh, say 4/3. Okay, and I gave you two options. I'm gonna put it in a different color. A 1/2. So we are looking at the benchmark 1/2 and 1. Okay, it's excellent that a lot of people will put in a fraction for 1, which is okay. But if you are given the option A and B, a half and 1, just follow the instructions. If you had a question which was not multiple choice and you gave me the answer as 4/4, 45/45, that's fine. Okay, but since I gave you the option here, choose the one of the options that I gave you. All right, so then what I would do, I would look at this. Now I would box, believe it or not, I can use cubes here. I'm circling the key numbers I have here, and then I'm going to box the keyword, map word, because this is important. I think that's the word that a lot of us were missing, because the objective of the exercise was just to um, make sure that you can identify the benchmark. Okay, and one of the things that we use benchmark for is we use it to compare fractions, to compare and order fractions. All right, so we use it to compare fractions and to put fractions in order. anyhow we want, from least to greatest, and so on. And so I would look at this and say 4 over 6, half of 6, half of 6 is 3. And so up here, 4 is more than 3. So I know this fraction here is more than a half. Look at this again. I have this thing here with 1, 2, 3, 4, 5, 6. I know half of 6 is 3. 1, 2, 3 is half of 6. But remember, the numerator tells me how many parts that I am choosing, I am giving out from the whole. So it says 4, but half of 6 is 3. So I know that I have to shade another one. And I'm going to shade it in a different color. So now I know that 4 over 6, I'm going to put it in red also, is more than a half. Can you see now? It's more than a half. So 4 over 6 is more than a half. All right, so I know this one is more than a half. I'm looking at 4 over 3. 4 over 3. Remember, the denominator tells us how many equal parts are in one whole. So I'm putting this in 4. Nope, not 4. The denominator tells us how many parts in one whole. 3. So I have to shade 4 out of 3. 1, 2, 3. Can I shade 4 out of 3? No, which means that I'm going to put another hole. 1, 2, 3. Now, can I shade 4 out of 3? Absolutely. 1, 2, 3, 4. I'm shading 4 out of 3. 4 out of 3, 4 out of 3 is one whole and 1 over 3. So I know that this is more than 1. So I know that this is more than a half, but this is less than 1, right? And this is more than 1. So between these two numbers, I already know that I can put it in order, remember? Order fractions, that's what benchmarking does. So I can say 4 over 6 and 4 over 3. I know this because of my model here, my diagram. I know the number, this is more than 1, this is 1, more than 1, and this is less than 1. It's more than a half, but it's less than 1. So I know 1 comes between. I know 1 comes here. 1 comes between here. Where does half go? Half goes before. Okay, I'm going to take this off just for some space. Half comes here. Because we know this number, we said this number, 4 over 6, is more than a half. And so our answer would be 1.